All right, on this next slide, we're going to take a look at. These are putting together some of the rules that we learned about rate of change. This is lesson 1.1, 1.2, and 1.3. I've merged some of this information here. So the first thing I want you to be aware of is what these things can mean. It says here, complete the table if y is equal to f of x, which I already put that there. G of x equals this. Now let us pause for a minute. Let's focus on this. G of x equals. Now, last class we talked about this 1.7. We compared the insides. On 1.7 we were doing even and odd. We had opposite x's. Now these are not opposite x's. How are the x's related here? This x compared to this x. Are they the same value inside? No. This x is 1 less than this x, or you could say this inside value is 1 greater than this one. Said another way, we have a change of x. How much did the x change by from here to there? 1. Okay, now, what's happened to our f values? We're changing the y's. How do I know? Because we are subtracting them. So we have, I know it looks like an opposite f values, but what's happening is we're changing the y values. Right now we have some change of y values because that's one f subtracting the other. We're taking the change of y here, and we have a change of x of 1. What is the change of y? Whoops. What is the change of y divided by the change of x equal to? What's that equal to? AROC. Well, in this particular case, what is my change of x? 1. So if you had the change of y divided by 1 equaling AROC, that would mean that the change of y by itself is, the change of y would be equal to AROC. This g of x, this is the AROC equation. G of x is equal to your AROC. This is the symbols because what's happening is it's saying your x's have changed by 1 and you're subtracting your y's. That's like y1 minus, or excuse me, y2 minus y1. That's like y2 minus y1. You could think of it that way because these would be different y's since they have different inside values. So all that is a fancy way of saying AROC. What do you think h of x being g of x plus 1 minus g of x is equal to? Any takers on what this would simplify to become? I'll give you a hint. It's g of x, this g of x, minus a different g of x. If you took one of these and subtracted a previous one, what would you get? Okay, let's go back through this one more time. What's happening with my x's? They're changing by 1. We have a change of x that's equal to 1. Up here we have a change of y's. Now the g though was already itself a change of y. So technically this is a change of y. How did I get that? Because what was g to begin with? G was the change of y. So that means if you now are changing your g's, you're changing the change of g y. Anybody figured out what this is yet? This is equal to the change of the average rate of change, the change of the AROC. That's what that equation is. That's just a weird way of writing it, but that is what those are. As we were going through these lessons, I gave you some relationships. Who remembers? If a function itself is concave up, what is true about its average rate of change? Always, always, always. If a function itself is concave up, what would be true about its rate of change? Not positive. That'll be an option, but this would be a wrong option. Increasing. You need to know that this would be increasing. That would be increasing. Okay, now if a function's concave up and its average rate of change is increasing, that means the change of the AROC. So I'll give you some examples. Increasing numbers would be like 5, 6, 7, 8, 9, 10. It would be like 5, 7, 9, 13, 20. It could be 20, 25, 29, 31, whatever. If these are increasing, what's true about their change? They're positives. You need to know that relationship. We'll call that relationship number 1. You need to know this relationship. Okay, let's go down here. We have relationship number 2. This says The change of the AROC is negative. If the change of the AROC is negative, what has to be true about the average rate of change?
Decreasing.
This has to be decreasing. Now, if this is decreasing, the average rate of change, that is, if the average rate of change is decreasing, what has to be true about your function? It has to be concave down on that interval. Any question about that? All right, so now what I want to do is this. I'm going to make up a number here. Let's say these are values on an interval where x is less than 2. Come over here and add that x is greater than 2 here. I'm just making this up. This is just for an example. This is just an example now. If this is when x is less than 2 and this is when x is greater than 2, let's talk about when x is equal to 2. That's going to be right on the line. If this is x is less than 2 and this is x is greater than 2, that means you were concave up, now you're concave down. Show me that with your hands. Your first hand, show me your left hand, concave up. Now take your right hand, concave down. Put them together. That in our problem represents the value of 2. What does the point at when x is 2, what does that represent? A point of inflection. Add that if x equals 2 here, we would have a point of inflection. Right here, this would be a point of inflection. Said another way, a point of inflection is where the point where concave up meets concave down. Or vice versa. It could go concave down first if you're wondering. It could go concave down meaning concave up. But where they meet, it's called a point of inflection. Okay, now this one. If you were increasing, show me increasing with your left arm. Left arm has to be increasing. Your right arm, give me decreasing. Put them together. Where they meet, that point creates something. That's called a maximum. Very, very good. This would be a maximum. Now, a different question. This time, what if the order was backwards? What if we first were decreasing and then increasing? Let's do that. Left arm decrease, right arm decrease. Where they meet, what does that become? Minimum. So the order matters on that one. It does not matter on concavity. It does matter for your extrema. Okay, what about the last one? You were a positive number, now you are a negative number. So I don't know how to do positives other than do a hand way up high, then another hand way down low. What comes in between those positives up high and the negatives down low? 0, right? This is right in the middle. 0. So put a 0 there. You need to know that relationship. Okay, last one. If this is a whole new situation, if f of x is a cubic function, what would that mean? What type of function would describe the average rate of change? If this was cubic, what would be true about its average rate of change? Quadratic. Yeah, why would it be quadratic? You lose the highest degree. So this would be some type of quadratic function. So you'd be looking for something in the form of ax squared plus bx plus c. And what would that make the change in the average rate of change? Linear. Y'all remember that? It always goes down, which would be something in the form of y equals mx plus b. It'd be some type of equation like that. John, you with me? Okay, so I have this table. I have another table. Before we start plugging in numbers, I have one more time. We're going to walk through this a second time. Let's see it again. New situation. Look up at the top. When you see g of x equals f of x plus 1 minus f of x, what is that telling you right there? That's a fancy way of saying the AROC. This right here is the average rate of change. That's a fancy way of saying the AROC. So g of x is equal to the AROC. And right over here, if g is the AROC, what happens when you take an AROC and you subtract another AROC from it? You get the change of AROC. So that's what h of x is here. H of x is equal to the change of AROC. I'm just showing you fancy ways that it can be written. That's using math notation. All right, questions up for you. If this is linear, this time I'm going to do a countdown. I want you to fill in what's true for this box and for this box. I just gave you the rules on the previous page. I want you to write down what you think is true for this box and this box. I'm going to pause the video. All right, picking up. If the g of x is linear, this column is linear, what has to be true for this box right here? Siri, what do you got? It has to be quadratic because whenever you're working with one of these tables, anytime you go to the left, you gain a higher degree. Anytime you go to the right, you lose a degree. This has to be quadratic. What's the form of a quadratic equation? Ax squared plus bx plus c. You would be looking for some type of equation like that. Okay, that's going to the left. Jamleth, if this is linear here and you go right, what's going to happen if you go right on your table? Will we gain a power or lose a power? You'll lose. So if we lost the bx, what are we left with? Just the c. What does c stand for? Constant. This would be constant over here. You need to know that relationship. That if you move left, you gain powers. If you move right, you lose powers. So that would be completing that table. Okay, here I've mixed up this table. This time I'm telling you f of x is increasing. What does that mean about f of x if it's increasing? What does that mean about g of x? The average rate of change. If you are increasing, what would this mean? This is positive. Very good, very good. This is positive. Why did you not say concave up? Concave up is when you move to the left of increasing. When you go to the right of increasing, it is positive. What if we go to the right of positive? We don't know. So do NA. There's nothing you can predict off of that. If you try to predict off it, you're going to be wrong. So put NA as in that's nothing to predict. Okay, how about the last one? What if the average rate of change is concave down? What would we put on the left? Not decreasing. NA. Why NA? We cannot predict to the left of concavity. You don't predict to the left of concavity. Okay, what could you put on the right? If the g of x is concave down, what is true about h of x? It would be decreasing. All the blue is true. You can predict it every time. The NA means you cannot predict. That's how the patterns work. So on the previous, when you look at these, I put them the way you normally see them. Normally it goes concavity, following by increasing, decreasing, followed by positive or negative. However, they do not have to be locked in these columns. You can switch them around, but just know, concavity, you cannot predict to the left, but you can predict to the right. Increasing, you can go one left and one right. Positive, you can predict to the left, but not to the right. All that to say is I should try to apply it here of when you could apply and when you could not. So make sure you know those tables. Now let's practice some with numbers.